I'm Shunto at Boston University, and I'm really excited to talk about can privacy technologies replace cookies, add revenue in field experiment. This is co-authored with Jen Gu, who just defended her thesis at BU, and so she's a now Dr. Gu, and she's joining McKinsey soon, so I'm really happy for her. And also co-authored with my awesome colleague Eric Johnson, who's also at BU. So digital advertising, many of you already know, digital advertising is a large industry that is used by many online publishers to monetize their content. So many people enjoy free content online because that content is monetized by digital advertising. So this is a multi-$100 billion industry. And what makes digital advertising special is that it has features like behavioral targeting or attribution. So behavioral targeting, based on your browsing pattern, they show you ads that are relevant to your taste. And also attribution measurement, by using technologies like cross-site tracking, they know what ads are instrumental in making you purchase certain things. And as I said, behavioral targeting, attribution, these features are powered by cross-site tracking. And cross-site tracking, it's enabled by identifiers like third-party cookies, and so on. And this cross-site tracking is useful for these features, but nowadays government and industry measures have been introduced to restrict cross-site tracking in various ways. So there's GDPR in Europe, CCPA in California, and other state-level regulations that allow users from opting out from being behaviorally tracked. And also there are industry measures like Safari and Firefox blocking third-party cookies by default. And that is good for privacy, of course, and maybe cross-site tracking can have some kind of potential harm. So maybe it's good, but the problem is that current digital ad technologies rely heavily on cross-site tracking. So removing this feature, this ability, may severely hurt ad performance and also ad revenue, which is used to fund most of the web ecosystem. So, both of these things are important. Is there a middle ground? And there has this set of technologies that are proposed or gaining traction as middle ground, but between or potential path forward. So we have these privacy enhancing technologies where industry and regulators hope them to be something like something that strikes balance between privacy and effectiveness. And what are these technologies? These essentially things that are designed to preserve core ad functions, so core features like targeting and attribution without relying on cross-site tracking. And I'm going to talk in more detail about how they function, but this is using techniques like differential privacy or federated learning that are already used in other environments like US Senators, for example. And there have been major efforts by tech firms, Google, Microsoft, and so on, that are, in trying to introduce these technologies into digital advertising, but their economic viability remains uncertain. And that brings us to our research question. First, what is the economic impact of deprecating third-party cookies? So this is something important to establish. And second, can privacy-enhancing technologies alleviate this impact from removing cross-site tracking? And in this paper, we're going to investigate these research questions by leveraging this really cool field experiment that was done by UK antitrust regulators, CMA, and Google. So this experiment involves randomized treatments that involve deprecating third-party cookies, so removing cross-site tracking, and then introducing privacy-enhancing technologies, specifically Privacy Sandbox, which is designed by Google. And because we have randomized treatments, they allow us to identify causal effects of removing cross-site tracking and then introducing privacy-enhancing technologies. To understand these causal effects, we obtain log-level, impression-level data from an ad management firm called Raptive. So this is the largest ad management firm that help publishers monetize their content. And this company has 5,000 online publishers. So we have impression level data, rich data from this many publishers. And what we find from this dataset and our methodology, so what we find is that removing third-party cookie hurts ad performance, ad revenue by 30%. So this is confirming prior studies that have looked at the effect of removing third-party cookies, effect of removing cross-site tracking, but using this large-scale field experiment. And what we find about privacy-enhancing technologies is that while they are promising and they make novel changes, they recover only 4% of that loss. So 30%, removed from ad revenue by disabling cross-site tracking, and then only 4% is recovered. 4% of that damage is recovered by using privacy-enhancing technologies. And we also find that privacy-enhancing technologies, because they rely on techniques like on-device computation, so that user data do not get leaked out. And that kind of on-device computation can introduce latency. And in some cases, that leads to missing impressions because people move away before ads are loaded. And we find that this is mainly coming from industry adoption, that these technologies are used for changing how market transactions happen. And because of how there's not a lot of adoption from both the demand side and supply side, we see only 4%. David?
Sorry, can you give us some more context on the experiment? Did you run the experiment? This was a Google experiment or something else?
So this was a large field experiment precisely to understand the impact of industry impact of Google's policy, Google's planned policy of removing third-party cookies from Google Chrome. So UK antitrust regulator, CMA, they were alarmed that it may lead to information monopoly by Google. So they worked together to have this field experiment. Basically, it's open ecosystem-wide field experiment that involves removing third-party cookies and introducing privacy sandbox to see where competition effect is alleviated. And we since it's open, any ad tech firm could join it and then collect data. So we partner with this ad management firm to study ad revenue impact.
Do you think that this represents more of a short-term impact?
Great question.
An environment where most advertisers are used to having this cookie information and therefore maybe make negative inferences when that cookie information isn't available? Or does this maybe more represent a world in which nobody has access to these cookies and everyone's kind of settled into this new norm?
Great question. So I think what we see from this field experiment is more partial equivalent story. So that's these firms not all of them adopted the technology. So we have limited performance coming from that. And then also there was huge uncertainty about where the future is. So Google, as I said, Google was planning to remove third-party cookies, remove cross-site tracking, but that they announced it in 2019 and they delayed multiple times. So there was not a lot of confidence where they're actually gonna move forward, and then they actually scrapped the plan anyway. So I think there was a lot of uncertainty about whether these technologies gonna be important anyway in the near future. So I think there are those caveats are there. But of course, I think it is important to look at real world performance. And one of the insights, I guess, from this field experiment is that we need commitment or adoption from both sides of the market. Any other question before I jump into the?
Is it fair to think of the treatment as specific to the platform that ran it? Do you think a smaller, less influential platform would get the same results if they ran the same experiment?
So this is an ecosystem-wide field experiment. So it's not each platform is doing it per se, but we do see industry reports. So not academic reports, but industry reports coming from other demand-side platforms or supply-side platforms that participated in this experiment. And I think the story is pretty consistent that there was limited performance. And of course, there's degree reports how how, how effective it was.
But when you say ecosystem, do you mean within the browser, or was this on all browsers?
This was so it was specific to Chrome users, but this is the open web, right? So the display ad market, the whole thing was impacted because there's browser level treatment. So, these browser, like Chrome users, like 1% of them got affected and, like their cookies were removed. And then, 0.75% got privacy sandbox introduced. Okay, let me talk in more detail about what privacy enhancing technologies are and also what these experiment I've been talking about. So privacy enhancing technologies, these are, not just like specific to ad, but these are technologies designed to preserve key outputs from user data while maintaining user privacy. And how do they do that? They may use strategies like differential privacy, which is introducing noise into input data while making sure that the output is like only has like epsilon difference. And also there are things like federated learning or decentralizing computation, so that like some of the key steps of computation are done at user devices, so that you only get like auxiliary outputs from user data and actually get accumulated at centralized server. That way, the underlying raw user data are not exposed to third-party servers. And they have been introduced into healthcare research or US census. And nowadays they're being introduced into digital advertising, so that we can remove our reliance on cross-site identifiers like third-party cookies. We have Privacy Sandbox developed by Google, and we also have Ad Selection API by Microsoft, Ad Attribution Kit by Apple, and Privacy Preserving Attribution by Firefox. So there are many different technologies, but we're going to focus on Privacy Sandbox in this paper because this was the most innovative and ambitious product out of these. So basically, this is a Google-led initiative that was launched in 2019, along with their initial plan of removing cross-site tracking from Google Chrome. And partly because of how there was an antitrust pressure against doing this like cookie removal plan, they invested heavily in Privacy Sandbox. However, Google abandoned the plan to remove third-party cookies and also abandoned Privacy Sandbox in 2025 amidst intensifying antitrust scrutiny like DOJ cases or other cases in EU. So much of the Privacy Sandbox is discontinued. However, we think privacy enhancing technologies remain a viable path forward because they are still getting developed and invested by other firms. And perhaps Google will come back later on when these antitrust cases are settled. So Privacy Sandbox, it's not just one technology. It's a suite of different technologies. So it has technologies designed for targeting and technologies designed for measurement. But for the purpose of this talk, I'm going to talk about the one technology that enables privacy preserving retargeting. So Protected Audience API, which I'm going to call PAPI. PAPI enables privacy enhancing retargeting. And this is like, it's doing really cool thing to like enable retargeting, which traditionally requires third-party cookies. So before talking about PAPI in detail, let me talk about how traditional retargeting works. Let's say Ty is going to Best Buy and then he browses HD TVs. Maybe he wants a new TV for his like shiny room or something. And that browsing behavior is going to be attached with his third-party cookie. So it's like an identifier used by Best Buy or ad tech firms. And Best Buy or an ad tech firm that Best Buy uses is going to record that browsing behavior attached to its third-party cookie. And this is going to be useful when Ty goes to the Washington Post or other publishers and start browsing. And if Best Buy is participating as an advertiser on the Washington Post, and what's going to happen is that his third-party cookie will be attached to ad auctions that are triggered by Washington Post at some ad exchange. And then Best Buy is going to see that, oh, this person is visiting the Washington Post right now, and he browsed HTTPs before. We can make a bid, and then if we win, we can show ads that involve these exact TVs he browsed. And then, if that happens, he's going to end up seeing an ad about these exact TVs when he browsed. So this process, as I said, involves third-party cookies, cross-site identifiers, and also ad auctions happening at third-party servers. How does Poppy enable retargeting without doing these things? The way it works is that when Kai goes to Best Buy, now instead of Best Buy, recording all this information, Best Buy is going to tell his browser, Google Chrome, to record their interest in showing ads about HTTPs. So now Kai's browser is having storing this information that Best Buy wants to advertise these products later on, and this is going to just stay on his device. So it's not going to leak out. But it's still useful because if Kai goes to the Washington Post and runs Poppy auction on his device, so it's going to be an on-device auction, participated among recorded advertisers like Best Buy. So even though this Best Buy's interest in showing ads only stays in his laptop, it's going to be used in running these Poppy auctions. And then if Best Buy wins, then he's going to see this retargeted ad. So that's how protected audience API works. Carr?
Well, one slight detail is missing here because in traditional retargeting, I am tracking a user. In protected audiences, users are allocated into audiences, discrete bundles of audiences. And so I've been in conversations with lots of companies testing these things. And the audiences have had two real limitations. Number one, misassignments in their view are pretty high. And second, where it's easy to show that sort of retargeting matches to someone who's been to the site, right? But in the context of protected audience, the audiences don't always quite match what people want to buy from retargeting. So it's better than nothing, but I correct me if I'm wrong.
Yeah.
I don't think this is at individual levels.
So I think there is another API called Topics API, which sounds a bit more like what you're describing.
Okay, so I think that's more the topics.
Yeah, so topics, yeah, exactly. So I know that there's privacy restrictions, so maybe there's some kind of noise added to this process, but protected audience API is a bit more individual level. So you can almost do retargeting.
So that's the one where the auctions run on the user's phone.
Exactly, like Android phones. And Topics API, so this is exactly what Carr described, people are placed into topics, and then ad tech firms only see this topic label, but that is happening on the classical, real-time bidding process. Protected audience API is fundamentally different, that it runs on your laptop or smartphone. Thanks for the clarification. Other questions? So as I emphasized, this protected audience API, so this is it gives similar end results. So you still get retargeted ads. However, as I said, it relies on on-device processes, on-device auction, on-device bidding algorithms. So these bidding algorithms are now working in your laptop. So these processes may introduce latency. So at delivery speed may get slower, and that's not great because if users leave before ads are loaded, then that's missed opportunity, right? Srinivas?
How does the auction work on the browser? Does Best Buy send a piece of code and submit a bid? How does Best Buy submit a bid?
Yeah, so Best Buy or whatever firm demand side platform Best Buy is using is gonna basically insert some kind of JavaScript or something that gets embedded in your browser, and then that's gonna do some kind of communication with servers, but it won't involve user level information. So it's gonna bid as if it's going on in the classical server, but now it's working in your browser.
Yes, my understanding is the auction, the winner happens right on the phone.
Yeah.
Right, and the advertiser never really knows too, because there's also a protective fence between the
Exactly, yeah.
retail site and the actual
Mhm,
device.
exactly. So, these like bidding algorithms are designed, so, it's like they take in like similar signals as classical way, but, they are designed to make sure like, user information do not get out. Other question about copy? I'm gonna keep saying copy. So, this technology sounds promising, it's really cool, but like how does it function in the real world? So we're going to leverage this industry-wide field experiment that was conducted by CMA, UK antitrust regulators, and also Google. So this experiment specifically was to assess the competitive effects of cookie deprecation and introducing privacy sandbox. But we're going to leverage it to just study the impact of cookie deprecation on publisher ad revenue, and making sure that privacy enhancing technologies can alleviate this impact. So again, ad revenue is really important because that's how most of the open web is supported. And this field experiment, it has three primary treatments. So two treatments in which these Chrome users. Just to clarify, this experiment involves Chrome users from across the world. So we have this random set of Chrome users where they lose third-party cookies. So third-party cookies, cross-site identifiers, meaning you won't be able to use classical technologies like retargeting or behavioral targeting using cross-site identifiers anymore. So cookieless treatment, 0.25%. This is what's happening, just third-party cookies are removed. But privacy sandbox treatment, we have copy enabled, protected audience API enabled, or I should say privacy sandbox itself is enabled. And that's why even though third-party cookies are removed, you may be able to rely on these privacy enhancing technologies for doing like these key ad features. And we also have status code group with third-party cookies enabled. So this is like business as usual. And we can use these randomized treatments to understand the causal effects of removing third-party cookies and introducing privacy enhancing technologies. So this was an open car.
Again, another point of clarification. So do all the DSP, DMPs, advertisers all have to learn how to use the API and weave these API calls into their line code? Which is a big lift, right?
Yeah, so in terms of like protected audience API, publisher side has to use like some supply side platform that already has this ability to use trigger protected audience API. So that part is, I think, it's like relatively simple. Like if you just use like Google Ad Manager, then they support that feature. But demand side platforms have to, invest in like having these bidding algorithms that can work on browser level things, and then also like dealing with these like signals that are different from the classical side. So they need to like invest heavily into adopting technology. Ron?
Are you focused on retargeting and protected audiences API or generally on privacy standards?
Very good question. So I only explained it. I explained protected audience API because this was the most ambitious API out of these technologies, but there are other APIs that are going on, like topics API, for example, and also there's like attribution reporting API. That's does privacy enhance attribution or measurement.
The reason I'm asking is that how many of these advertisers were using retargeting before? Not many of them were doing retargeting anyway. You change something, you won't see that much.
Yeah, so in terms of retargeting, we have like advertiser side study. So this is publisher side study.
Right.
For the advertiser study, we collaborate with demand side platform specialized in retargeting. So there we can do like this kind of like more kosher comparison, and we find that if you look at per dollar ad performance, it's like does quite well in terms of like how many conversions advertisers getting. But in terms of publishers, so I know like retargeting is something that's influential, but of course not everyone's retargeting. So I guess we have to keep that in mind. So like for firms that are not doing like retargeting heavily, maybe it's like more like topics API or this attribution and attribution reporting API. So for this talk, you can kind of like primarily think about protected audience API as a primary thing, but there are other effects that are hidden in the privacy sandbox, and now we're working right now to decompose it. But today I'm just going to show you like this sandbox effect, and it could be coming from protected audience API or other APIs. But we think it's mostly protected audience API, anecdotally. So we collect data. So again, this was an open ecosystem-wide field experiment, kind of like unprecedented. Like they just do this experiment and then tell like online entities that like you can just join it and collect data. So if you knew how to deal with these things, you could collect data and with information about which treatments like these users are assigned to. So we partner with Raptive, which is one of the largest ad management firms that help publishers monetize their content. So they collectively represent the top 10 digital properties. So they experience a lot of traffic. And we obtain impression level data from 5,000 publishers that use Raptive. So this contains like 207 million ad impressions. And these are all served to these experimental groups I mentioned. For impression characteristics, we have treatment label, device type, and which country they're from. And the key outcomes, we study ad revenue, so CPM, and also ad delivery speed. So let me explain about the results, but before we go in, let me talk about what we're going to do. So we already have this, data from experiment with randomized assignments. So we can use these to obtain treatment effects directly. We're going to focus on relative treatment effects on ad revenue because we want to know like the relative effect compared to the, having third-party cookies turned on. So it's going to be normalized by the status quo average. So again, status quo means business as usual, cross-site identifiers are enabled. And for the cookieless effect, we can just compare the cookieless group that lose third-party cookies and the status quo group. So this is trying to obtain the effect from removing cross-site identifiers and how much of ad revenue will be disappearing. And sandbox effect will be comparing the sandbox group and the status quo condition, so that we know how much privacy sandbox is working. Like, is it working as well as cookies or not? So we have these treatment effects to contextualize what is going on. So let's go one by one. We have cookieless effect. And we find that cookieless effect is like 30%. So there's 30% drop in the ad revenue when we remove third-party cookies. So this graph is saying that if we say status quo average ad revenue is 100%, cookieless ad revenue is 71%. So this is a massive drop. Like usually we say like single-digit percentage in digital, digital economics is like peak effect already, but like this is the only one of the only cases where you see like huge effect like this, and this is actually very consistent with prior work. So we have people in this room who have obtained the cookieless effect from observational methods. So this is we use a large field experiment to confirm that previous estimates are aligned with what we have here. Ron?
How do we interpret this? What do you think is the cause?
Yeah, so it can be, so as I said, third-party cookies instrumental in like behavioral targeting, right? So one reason is that, these advertisers, demand-side platforms cannot help advertisers who target effectively. So there's a drop in the valuation. Oh, but there's also like the second reason is that, this is not something that's appreciated often, but third-party cookies are also essential in measurement and attribution. So, like which demand-side platform, which ads are contributing to your conversions. So if they cannot track that, then there's also a lot of value from that.
So the reason I asked is it seems a massive.
Yeah.
I say, oh, taking cookies away will decrease the size of the ad space.
Yeah.
But if you're an advertiser, say 99% of the people have cookies and 1% so they don't, just take the budget to one place. And what you're seeing here, it's just the budget went somewhere else. It's not like the effect of inefficiency in the market.
Yeah, so I think it's not specific to this field experiment, but like removing third-party cookies is kind of like, it's going to be like partial equilibrium in the sense that there's like,
Right.
Yeah, I mean, and I think, so I think it is true that it can be like a partial equilibrium, but if you think that impressions are horizontally differentiated and you need cookies to make sure that, what whoever like showing ads to like, are actually interested in the ad, I think kind of makes sense that valuation would drop.
Can you repeat this question again, Ron's question? If the portion of treatment that was cookie-less was much larger part of the market, would you still expect to see such a large effect?
So I think depends on what we're talking about, right? So if it's like, if we just remove entirely today, then I think we're going to see a massive, like
So that's
similarly
what we
massive
care
one.
about, right? We
Yeah.
care about the board where there's no cookies, right?
Mhm.
The experiment is shifting, I think, a tiny sliver of traffic without cookies.
Mhm.
And do you think that's a lower bound on the effect of that? Like maybe much smaller? I think that's what Ron is also asking.
Yeah, I mean, I think in terms of like open web, like the ad revenue that these digital publishers getting, I think it's, it's like, I think the magnitude should be similar if we actually get like cookies like removed, but if you like include like walled garden or something, like I think that's gonna shift the story.
Just a short follow-up, do you see the good advertisers are, do they spend less money on average than across everyone?
Mhm.
Because then you can kind of claim, I see the budgets are shifting, or I see the thing.
Yeah, so we don't have like, I mean, I guess we could do like advertiser level
That would be
study
my
or something, yeah.
Help you kind of disentangle maybe.
Yeah.
So couldn't it also be created under the tier use cases? Not advertisers.
Might be, but.
Yeah, I think they could be like, I mean, they can be like budget shifting and also like entry.
Right.
So it's like, so general equilibrium is like it's like, I mean, I agree it's important, but it's like hard to say from the like experiments or like using observational data sets. Maybe like it requires some kind of like, I mean, Guy Ardo has like paper about like, going like meta or something. But maybe it would require a structural model if you want to get like entry of that.
So this is a different angle on, a little bit different angle here. So the reason all these privacy regulations are being implemented from a consumer behavior perspective is people hate ads following around on the internet. You look at shoes, there's a shoe ad, you buy the shoes, you continue to see the shoe ad, right? If I developed a perfect system, privacy compliant system, where as a consumer, I see the exact same stuff. How do we solve the problem? Why wouldn't consumers still be angry and want it? You see what I'm saying? Like I feel, dude, I don't think consumers know how ad auctions are conducted. In fact, I'm guessing a lot of people in this room don't even know. It's like, why? You don't have to answer this question. It's a bit of a tangent, but
Yeah.
but I feel like this approach is kind of missing point.
So what would be like
Tell you what, we'll talk about it. I know.
Yeah. So I know, like, I think some people, like, I don't know how much, but people are like generally like concerned about like their data going to third parties. So if like, I think depends on like how much heterogeneity, like how much like different people have like ad avoidance, or like they don't like ask, then I think like it's hard to address. But I think if we want to actually get like some kind of middle ground, at least we should look into like these kind of technologies or do some kind of like propose new thing that's brings a middle ground, help us. But let's discuss offline. So status quo group. So one thing to mention that this is like intent to treat, in the sense that status quo group already contains cookieless impressions. But so if we can if we adjust that using like local average treatment effect or looking at ATT, the effect becomes more like 35.3%. And I didn't talk about the standard errors, so you can look at the confidence intervals because we have a lot of data. That's what we get. But like if we want to make it like extra robust, like we can do clustering, and we have done like clustering by publisher, region, and so on, and the results still holds. And so what we learned from the sandbox effect. So it turns out if you look at the sandbox effect, it only recovers 4.2% of the impact from removing third-party cookies. So compared to the status quo average, Sandbox is getting 72.2% as ad revenue. So it is, better than the cookieless ad revenue, but only marginally. So of course, this is like 1% difference. So maybe given the volume, it is, making a difference, but it's not recovering like all the way up to 100%. I don't have time too much time to talk about geographical heterogeneity, but we find that if you look at European Union, it becomes more like 22.5%. So in Europe, it's performing better, but again, if you look at the all impressions, it's more like 4.2%. So what is going on? Like, why do we only see 4%? So one reason we see is that there's challenge coming from latency. So we have protected audience API that is happening on user devices. So if you have crappy laptops, then you're beating out with the speeding algorithm auction stuff happening. It can slow things down, and you may get ad really slow, and you may just leave the web page. You may just bounce before the ads are loaded. And in fact, if you look at the delivery speed, it's almost twice as slow as the status quo and cookieless groups. And in some cases, we find that it may lead to missing ad impressions. So people just leave before ads are loaded, and that happens about 3%. And this is obtained by looking at how many ad impressions we have in the data set versus like what is the randomization probability. So 0.25%, 0.75%, 1%. Like we just compare it and then see how many impressions we should be seeing, but we do not in the data. The second challenge is that there's industry adoption problem. We find that only 7% of ad impressions are actually served through protected audience API. So even though Privacy Sandbox group has these technologies enabled, it's not utilized often. And we also see that in the data, only 4 ad tech buyers, demand-side platforms, are actually using this technology. So there's demand-side problem, but it's not only the demand-side problem, it is also supply-side problem because this is like a chicken or the egg adoption problem. It's multi-sided. For the consumer side, if Google Chrome is enabling it, then they kind of adopt it. But for publishers and advertisers to adopt, you need adoption from both sides so that demand-side platform, it is worthwhile for them to invest in these technologies and start using it. And also for publishers, they need to see demand-side adoption to make sure that it's not like it's not a bad thing to implement these technologies. And this problem was compounded by uncertainty over Google's future cookie policy. So Google's plan of removing cross-site tracking was delayed multiple times. So there's not a lot of credibility that Google would follow through. And also CMA's, it was not clear whether it would approve Sandbox and commit to or encourage firms to use this technology. Okay.
Question, to give options and issues, can we look at this 7% impression someday that makes a comparison?
Yeah.
So it's something that produce the challenges. It's conceivable that fix those challenges. The latency problem, fix it problem, on the
Is there any sort of like estimate, like approximation, or if these are fixed, what happens?
Yeah, so we're thinking about doing that, so like some kind of controlling for, this kind of like quantity. But the problem here is that Poppy is like working alongside the classical system. So there's like kind of like competition going on between these two options. So it's hard to think about like how to incorporate that. But for the advertiser side paper we're working on, we do like account for like expenditure that advertiser spending. And if you account for expenditure, the ad performance is more similar between Sandbox and the cookie system. So at least for the that side, we know that's like once you account for quantity, it's good. So we had this adoption problem and also uncertainty. And so our findings should be understood as a partial equilibrium, but it does give you the first real world performance, like how well this privacy sandbox can work if we were to just deploy right now. So let me conclude. Our field experiment evidence shows that privacy sandbox had limited performance. And this is primarily coming from latency issues, on-device processes, slowing things down, and also this adoption problem, right? So not a lot of firms were using this technology. And our findings, along with industry reports from other ad tech firms, informed CMA and Google to discontinue their decision to discontinue privacy sandbox. And this was amidst intensifying antitrust scrutiny on Google. However, as I emphasized, if you look at the advertiser side and account for ad expenditure, like if you look at the per dollar ad performance, incremental conversions per dollar, privacy sandbox is performing much more comparably to cookie-based system. So maybe what we need is that policymakers and platforms to better encourage or commit to the adoption of technologies. And finally, this study also demonstrates how an ex-ante ecosystem-wide field experiment can be useful for guiding policies that affect how markets function. So currently, we're trying to disentangle these different technologies housed within privacy sandbox, because right now sandbox effect is just there, and we think it's primarily coming from protected audience API, but it could be coming from other APIs like topics API or attribution reporting API. So we're working on analysis leveraging events that turn off and on protected audience API to decompose it. So it's kind of like diff and diff, but we're doing it in field experiments. So thank you for listening, and thanks all.
So can I ask a question?
Oh yeah, for sure.
So you showed us.
No, kidding.
I have seen her slides, not that many. Just few. So you showed us some results that was interesting. The latency stuff.
Yeah.
I found them fascinating. Do you have any idea of if there is heterogeneity in terms of how difficult is it for developers? Because latency is very important.
Yeah.
Right? It can really lead to a lot of bounces. Is there heterogeneity there? And if you go look at places where these things run fairly smoothly, do you see that gap getting closed more by the sandbox? Because you said, I can't close the gap. I'm trying to understand whether we should be worried about, the G's, because those things you showed us don't have that general equilibrium issues, right? It's the technical difficulties of facing that. I wonder how much of that gap can be closed.
Yeah, so I didn't get to discuss a lot about heterogeneity, but we do know there's like heterogeneity across devices. So maybe smartphones like have more of this latency problem than computers. And we think maybe it's also could be also coming from like the nature of the ad itself. Like if the ad is like heavily technical, then it may not the latency effect may be like stronger anecdotally.
And do you think the gap closing more in those places?
So in terms of the gap, so in this sample period, we don't have like an event that's closed gap, but we do have a period where they started doing this Poppy auction. in parallel with the cookie side system, like the real classical real-time bidding process. So in this sample period, they're doing like sequentially, like doing real-time bidding process first, and then Poppy auction happening later. So these guys that develop pre-bid, like header bidding technologies, they figured out a way to do parallel, and we think that that can close the gap.
Right, okay. Yeah, no, we have 10 minutes, I'm next.
Okay.
Yeah.
Thank you, everyone. All my discussion points have been actually already discussed here, so I'll do my role, try to summarize the discussion points, okay? So, what about the paper? It delivers headline results, right? Very easy to see. Surprisingly, like removing cookies, it drops revenue, but drops revenue to such a striking result, like 29%. So what does this tell us? It tells us something like after years of spending investment in protected user API, sandbox users, on-device auctions, it didn't move the needles for publishers. Okay, so this is striking. Second, right? Let's think about, this paper, like what's the beauty of this paper? Why this paper was selected here? I think like it's kind of hidden in the top. So to me, at least 2 points striking. The first thing is about the experiment setting. It is not an experiment. This is an open experiment. To appreciate it a little bit more, think about any time Google is running the experiment on there, right? Using 2% of their users allocated to 3 conditions, status quo, cookieless, and sandbox. But we, potentially advertisers or publishers, we did not see their allocation. But here, it is different. This is not a platform self-study. It is like in an open room with regulators in there. So you publishers actually see their assignment. This is important so that they can do this independent measurement using any publisher side data. Okay, so this is why for them, they actually see, right, what they can see and what they cannot. They can see effectively from the relative side, right? Their CPM, their topics API being allocated, whether the ad was delivered and what's the ad latencies. But meanwhile, at the same time, what they cannot see is they cannot see advertiser ROI. They cannot see the bidding behavior, conversion results. They don't know the budget allocation. They don't know the general equilibrium of price adjustments. So this is what they cannot see. Okay, so let's keep that in mind while moving along the discussions. The second point of this study is for the sandbox. People had high hopes on, Google had high hopes on. Only 7% adopted it. So what does that mean? 93% didn't use it. So what are they using? That 93% actually is using something else. It's a literally hybrid, like a batched algorithm on there. 93% is using, right, potentially some of the first party data, identifier like a logged-in users' email IDs, or maybe some conventional clouds like service options using the web page like keywords, identifiers, or page content. So essentially, we're only looking at that 7% like results. Okay, 7% like a user effect. So with those 2 things in mind, like we can appreciate even more why in their paper they find like the effects of sandbox actually is a sharper decline for EU. Why? Because the fallback system is weaker. The fallback system is essentially in the walls to see if there is alternative identifier of users. With stricter privacy rules, that means like less potential to identify users based on the alternative information. Okay? So this is what essentially is there. So some of the thoughts, my thoughts along this line or summary of our discussion points. I have 4 points up there. The first thing is, I think has been mentioned a number of times before, right? So this is not a global critic. This is a causal effect study with partial critical taking the publishers like a perspective. But we are all wondering what's gonna happen in the cookieless like world or in the sandbox world. What's gonna happen there? There are multiple players in that room. There's involving advertisers, involving like platforms, involving the bidding algorithm out there. So potentially in that world, if any of us had data, what we want to study there is, if that happens, would advertisers reallocate budgets to platforms with better first-party data? Okay, and whether platforms can gain more shares. And would this effect, like Ken said, or you have confidence to see similar effects, dramatic 30% reduction with a small platform? Okay, and for the bidding auctions, are we see the prices being adjusted higher, lower? What about that? Okay, so there's enough room to study what's going to happen in that ideal world. The second thing, right? Adoption 7%. In the paper, it positions that as a limitation, but in my view, it is not, right? It is a strategic, like endogenous outcome, not a limitation. Technology itself does not, but the market quite often fails. Okay, so we can study, right, potentially why there is no adoption. Is it because there is no announcement enough, like no enough education for the to the publishers, to the websites, to the advertisers, what to do in a world of sandbox or cookieless IDs? So is it because of the call automation failure, strategic resistance, or switching cost? And for those who adopts first? Does it depend on a number of factors like firm size, vertical integration, reliance on third-party data? And they have actually, I think, potential to ask those questions because in their data, they have enough variations across publisher size and also geographic potential environment, regulators as the IDs. Okay, so I think that's something like for them potentially to study. The third thing is about mechanism of decomposition, right? So for the mechanism of decomposition, we are all wondering, for that 29% like a revenue loss, why did it go? Due to what? Okay, this is not like by no means a exclusive listing of potential mechanisms, but I think at least there is a targeting reason, there's measurement reasons, and there is like a latency reasons. So targeting, if it does not do well targeting, maybe I should switch. Measurement, if it does not report back information to me, how am I going to track it, right? And latency, if it's too slow, then maybe it's not going to pull out the ads and lose the potential like to serve the audience. Okay, and how can we decompose it? It's a hard question, no problem. So potentially, I think there is at least a few opportunities for them or everyone here to study indirect evidence, to provide some indirect evidence. The first is if targeting plays a key role, then shall we see like more effect for retargeting than for targeting ads? And potentially they can identify whether the ad is for retargeting if they has a goal up there. Second, within the sandbox comparison, there's some cool setting is there's like alternative bidding algorithm going on. And there also adds latency being reported for different algorithms. So it's almost like a 2x2 designs. They can actually look at for those, given the same latency effect, right? Compare those protected user API versus the traditional like bidding algorithms to see what is the revenue impact. Or they can actually look at certain bidding algorithm and to look at high versus low latency to see what is the revenue impact. So potentially to answer those questions, is it due to simply latency, or if latency technology can be solved, will we still see some of the effects going on? Okay. And the fourth point is the privacy performance frontier. So we know that Google actually abandoned Sandbox after 6 years of investment in October 2029. So what does this mean for this paper? Does that mean like there's no point to further study the Sandbox issues? I think my like impression is no, right? Because from this paper, we almost know there is essentially a trade-off between performance and privacy. And in this paper, they are telling us how far current technology is from replacing cookies. And for further research to continue on this line, what can be studied is to see not whether Sandbox works, but how to shift this frontier, right? To push in the frontier so that potentially we can reserve performance, but at the same time, like protecting privacy. Okay, so those are the 4 points like I had in mind after reading this paper. So hopefully it's a good summary of everybody's discussion. Thank you.